Hi, it's Mr. Bennett here. Now today we're going to be looking at Chapter 9. Just letting you know that the three exercises that you must do are 9C, 9D and 9E from the chapter. Now, basically before we were using a different method to solve something like this for a 2 by 2. So what we did was, remember, we detached the coefficients and we made three matrices, and then we went through a matrice operation and used the inverse to actually solve this. Well, what we're going to do today is actually looking at an idea of using row operations. Alright, so the first thing is what we have to do is we have to detach the coefficients, which we're talking about here, and we need to produce an augmented matrice. So this matrice over here is an augmented matrice having a dashed line going down here, and so all the numbers basically get put in over here. Now the idea of doing row operations is that we want to get 3 zeros down the bottom here. Alright, so we want to do this so we get the 3 zeros. Once we've got the 3 zeros, then we can equate our x, y's and z's to solve the equation, right, or find the unique solution. Alright, so let's just get on to doing an example. So let's looking at this one here. We'll do the row operations for that. Right, so what we're going to, first thing we're going to do, we're going to say this one here is row number 1, row number 2, row number 3. Now we could swap these around. That doesn't have to be row 1. We can make that row 3 and write this down the bottom. Alright, these are interchangeable, so don't feel like you've got to just fix it as it is. Now the first thing we're going to do is we're going to get zeros in this region here. So what we're going to do is we're going to say row 2, because this is where we're making the change, so therefore we have to say row 2 becomes equal to something like 2 row 1 and take row 2. Because they've got a 2 here, what we have to do is make that a 2 as well. So what we do to that first line, we have to do to every term in that line. So that means that will become 2, 2, 2, 2 times 6 is 12, and then what we do is we take that equation. Alright, so therefore, now you don't have to show this, you don't have to get marks for doing that, but I think it's worthwhile doing because what it will mean is you are more likely to get it correct. So it's worthwhile doing and showing those steps. So obviously when we do the subtraction, so 2 take 4 is -2, 2 take 1 is 1, 12 take 5 is 7, so that's what I write in here. The next line, I do the same thing simultaneously, row 3. We want to get row 3, so what we're doing here is we're saying row 3 is becoming to equals 2 row 1, take row 3. Now I could quite easily say it's row 3, take 2 row 1. It doesn't really matter as long as you're consistent with what you're doing there. Alright, so doing that, and I think you can follow the mathematics there quite simply. So that's going to be simply 2, 2, 2, 12, take row 3 is going to give you a 0 there, -1 there, 2 take 1 is 1, 12 take 6 is 6, and so that's what I'm writing there. Now my next goal is to try and get a 0 in this point here. Alright, so obviously I need to be using row 2 and row 3 to do that. Alright, so again, I don't need to do anything for the first row, and so therefore I've got the -2 there. So what I would need to do is say row 3 becomes something like 2 lots of row 3 take row 2, and then that will make them the same. Alright, and that's what I'm going to do. So that is going to be 2 lots of row 3, which will be -2, 2, 12, take row 2, which is -2, 1, 7, and that should give me an answer of 0, 1, 5. In this situation here, we now have, with our particular goal, this is our goal of what we're trying to do here. Right, remember we were trying to get, in this particular section here, we were trying to get 3 zeros. Right, that's our triangle of zeros that we're trying to get. So now we can equate things. So what we can say here is Z is equal to 5. Okay, so we've got Z is equal to 5. Now next row over here, right, when we start talking about that, we now have this row here, in our particular matrix. So that's where we're starting over here. Alright, so now we can say minus 2y plus z equals 7. We know what z is. Z's equal to 5. Okay, so we put the 5 in there. And then what we can say is minus 2y is equal to, obviously, going to be 2. 2 divided by 2 is negative 1. So that's our y value. And then what we do is, because we know our y and our x value, we go back to our original row 1, which is x plus y plus z equals 6. So we substitute in our values for our y and our z, and we solve that and we get that. So what this means is we're going to have a unique solution for this particular equation. Now, we'll talk about this in class, but what that actually really means is that there is only one point in space. Now, we could be talking about a three-dimensional space situation, that all three equations actually meet. Right? So it could be for a situation where you're looking at the number of, or the price of basically 3 items that you're buying. It could be that that's the price. That's the only price that would fit those three equations. All right. So hopefully this makes sense. But yeah, that's the terminology we need to use for this one. It's a unique solution. All right. So I will do another video in a second showing you the next thing, which is doing one of these when you have an unknown. Because we have only numbers there, what you could do is also use your calculator here to solve that. And I would certainly encourage you to use your calculator to check that. So what you need to do is you need to go into your matrices. I've already put it in just to save some time, but number 4, if I just put that in, you can see that I've put those numbers into a 4x3 matrix. Alright, now on your calculator, if you also go into matrices now, go to the maths bit, right? So that's where you do your determinant. Same point, if you come down here, it has a thing called RRF, right? So if you come down to RRF, right, select that one there, and then we do matrix C. Oh, we'll have to delete that. And right, so if we now go to matrix C and come down to D, which is number 4, right, it actually solves that for us and shows us what the solution is. So certainly if you get asked to show the matrix C how you actually do the operations, you need to do that by hand. Right? If you don't have to do that, then this is the way you actually would solve it using your RRF button. The alternative is also to use the equation solver in Polysim 2 as well. That's another way of doing it. But this is probably the easiest way, and that gives you your sort of knowledge where you're looking for that. Alright, so again, obviously x is equal to 2, y is equal to -1, and z is equal to 5. Alright, we'll do another example very soon, so I'll talk to you soon.